Hello everyone. In this video, I'm going to talk about the Laar equation. This equation is also helps to know the behavior of components in the binary solution or behavior of components in the solution or in the mixture. Right? This is also a model for activity coefficient models for liquid mixtures. So now let's discuss this equation. So this equation are applicable for liquids for which when x1 x2 RT upon GE is plotted versus x1 at fixed temperature, a straight line is obtained. Similar like previous one, 2 parameter 3 suffix Margulis equation. Here also when we plot the graph between x1 x2 RT upon GE versus x1, we should get a straight line, right? And the straight line हमें बताता क्या बताता है द बिहेवियर. जब आप देखते हो तो वी नो दैट द राउल्ट्स लॉ अगर आपने पढ़ा है, हमने ऑलरेडी डिस्कस किया हुआ है. सो राउल्ट्स लॉ में हमें क्या दिखाई देता है, स्ट्रेट लाइन मिलता है जब हम ग्राफ प्लॉट करते हैं, राइट. सो सिमिलर वे हियर ऑल्सो वी शुड गेट दिस स्ट्रेट लाइन व्हेन वी ड्रॉ द ग्राफ. और वो हमें क्या बताता है, तो बिहेवियर की कैसे बिहेव कर रहा है आपका सिस्टम when you change any parameter in the system or in the solution. जब आप कोई भी पैरामीटर को चेंज करते हो while keeping others constant, तो वो सिस्टम में वो पर्टिकुलर कंपोनेंट कैसे बिहेव करता है. सो बेसिकली द पर्पस ऑफ ऑल दीज लिक्विड models for liquid mixture is to know the behavior of individual component in the solution or in the mixture, right? So therefore for such liquids you can write this equation in this term where B and A are the two parameters and these two are the functions of only temperature. So here it is very important. In this case these two parameters B and A, these are the constants or parameters which are the only function of only temperature. Now just rearrange this. So GE upon RT, x1 x2, reciprocate this. So once you reciprocate this, what we get? G upon RT x1 x2 1 upon x1b plus x2 upon a, right? So just x1 x2 take over here, then x1b plus x2a. Now just multiply it similar way जैसे हम last time किया था, multiplied by n both side. Same steps है. So n GE upon RT n x1 x2 x1 upon b plus x2 upon a. Fine. Now we know that x1 is equals to n1 upon n and x2 is equals to n2 upon n. So just substitute over here. So n x in place of x1 n1 upon n, n2 upon n divided by n1 upon nb plus n2 upon na. Fine. This n is cancelled. Here it is n1 n2 upon n and again n is common. So n1 plus n2, here it is b, here it is a, and 1 by n. So this n is cancelled. Then GE upon RT is equals to n1 n2 upon n1 b plus n2 upon a. Now this is your equation. Now we differentiate this equation with respect to n1 while keeping temperature, pressure and n2 is कांस्टेंट. तो पहले आप n1 के टर्म्स में डिफरेंशिएट करेंगे एंड देन फिर आप उसको डिफरेंशिएट करेंगे इन द सिमिलर वे n2 के टर्म में. फाइन. n1 एंड n2 क्यों आप कन्वर्ट करते हो, बिकॉज वी नो द रिलेशनशिप डाबा एंड GE अपॉन RT, राइट, विच इज इन डाबा एंड GE अपॉन RT क्या होता है, ln ऑफ गामा 1, राइट. सो एक्टिविटी कोफिशिएंट मिल जाता है एंड देन वी कन्वर्ट अगेन नंबर ऑफ मोल्स n रिप्लेस बाय x1, क्योंकि हमें क्या चाहिए, मोल फ्रैक्शंस के टर्म में चाहिए, बिकॉज वी नो दैट किसके बिटवीन हमें ड्रॉ करना है ग्राफ मोल फ्रैक्शंस के, इसलिए आपको हर बार कन्वर्ट करना पड़ता है. फाइन. सो यूनिवर्सिटी एग्जाम में आपको पूरा डेरिवेशन सॉल्व करने के लिए आता है, गेट में फॉर्मूला बेस्ड क्वेश्चंस आते हैं, तो आपके लिए दोनों ही इंपॉर्टेंट है। जो यूनिवर्सिटी एग्जामिनेशन के लिए प्रिपेयर कर रहे हैं उनके लिए डेरिवेशन इज इम्पॉर्टेंट, एंड यू नीड टू अंडरस्टैंड द कंसेप्ट ऑल्सो कि कहाँ आप यूज कर रहे हो ऑल दीज मॉडल्स। एंड जो गेट के लिए प्रिपरेशन कर रहे हैं उनके लिए ये डेरिवेशन से फॉर्मूला कैसे आता है और फिर उसका यूज आप कैसे करते हो क्वेश्चन सॉल्व करते समय। सो नाउ लेट्स okay, so now we are here and we have this equation. Now differentiate this equation with respect to any one component. So here we differentiate with respect to n1, component 1, and keep temperature, pressure and other component 2 is constant. So let's differentiate this. So dabba n GE upon, or just write down, differentiate the above equation with respect to n1 and keep n2 temperature and pressure constant. So dabba n GE on RT, dabba n1 temperature, pressure and n2 is constant. Here again we apply the u by v rule. So here u, this one, and v. So first v is remain constant, so n1 upon b plus n2 upon a is constant, and differentiate this. So differentiation of n1 with respect to n1 is 1, so only n2. Then now keep minus n1, n2 is constant, u is constant, and differentiate this. So 1 upon b. Okay, and here n1 upon b plus n2 upon a whole square. Right? Now here in place of this, let's just write down one more step. n2 minus n1 n2 b, here it is n1 upon b plus n2 upon a whole square. Here again n1 upon b plus n2 upon a whole square. So this cancel, and now we convert n1 upon n in terms of x1, right? So यहाँ पर आप directly you can just put x1 or in place of n1, and you can put x in place of n2, x2. जो n टर्म है वो दोनों जगह डिनोमिनेटर में ही आएगा, ऊपर भी और नीचे भी, so cancel हो जाएगा. So there is no need to write down this. So directly substitute this. So in place of n2 you can write x2 minus, here it is x1 upon b plus x2 upon a, then minus x1 x2, then b x1 upon b plus x2 upon a whole square. Okay, and this will be equal to ln of gamma 1, right? Now just rearrange this. So ln gamma 1 is equals to x2 upon ax1 plus bx2 or ab here minus x1 x2 a square b square upon b ax1 plus bx2 whole square. Now just take the LCM. So b ax1 plus bx2 x2 ab minus x1 x2 a square b square upon b ax1 plus bx2 whole square. So this is equals to ln gamma 1. Now just open the bracket. So a square b square, right? A square b square x1 x2 plus b cube 1 2 3 b cube a x2 square minus x1 x2 a square b square square upon b ax1 plus bx2 whole square. So this is, these two cancel हो गए और ये b से square. So here we have b square ax2 square upon ax1 plus bx2 square. So this is ln gamma 1. So we just keep a here and b square x square को नीचे लेके जाओ. So क्या हो जाएगा, ax1 ये हो जाएगा bx2 plus bx2 upon bx2 whole square, right? So ये cancel. So ln gamma 1 is equals to a upon bx2 to 1 plus ax1 plus bx2 whole square. So ln gamma 1, the activity of component 1 comes a1 plus ax1 upon bx2 whole square, right? So this is the first relation, Laar equation. Similarly, you can write for the component 2. So it will be 1 plus bx2 upon ax1 whole square. So these are the two relations. First one, when we differentiate with respect to n1, and for this equation you need to differentiate with respect to n2 while keeping temperature, pressure and n1 constant. So it can be seen that for infinite dilution of component 1, when x1 tends to 0 and x2 tends to 1 and gamma 1 tends to gamma 1 infinity, therefore we get ln gamma 1 infinity is equals to a. And similarly for infinite dilution of component 2, when x1 tends to 1 and x2 tends to 0 and gamma 2 tends to gamma 2 infinity, then we get gamma 2 infinity is equals to b. So these are the two important relations, and this is all about the Laar equation. Thank you.